Welcome to the Chapter 13 Introduction to Classes and Objects. And so objects are really dynamic in our ability to save space, save code, reuse code, which is really what we've been developing throughout the year as we've learned to parse out and decompose our algorithms into very specific tasks. Objects also allow me to create um, several objects of the same type, and I can reuse variables, I can reuse functions to implement them. So let's get started. So procedural programming, which is what we really did in the early days, really focuses on the process and the actions that occur within the program. Object-oriented program is based on data and the functions that operate them. Objects are instances of ADTs, that's advanced data types, that represent data and its functions. And so our arrays are a form of advanced data type, but objects and some of the other things we learn in AP computer science are even further advanced data types. So classes and objects, one of the really fundamental ways to think about it is that a class itself, a class is a full set of code. All right, you write your int main and even the function supporting it, but that file is a class. So a class is a blueprint, and the objects are the things from which I can make from that blueprint. And so the blueprint really is a layout of what a basic object might look like, but then when I create the specific objects from the blueprint, it might have some different characteristics to it. And so the image that we usually think about is a draftsman blueprint of a house, and then from there I can create as many houses as I want. And we can still tweak, maybe the number of windows that I have, or maybe how many doors that I have, which way the door opens, which way the door closes, and so forth. So those are some of the things then that become unique about each individual object, but the idea that all of the objects share the same type of characteristics, in the general structure of it. So some things that we need to keep in mind. What is an attribute? Attributes are members of the class. And so attributes also define the specific characteristics of the class. And another term I'm going to use to describe attributes is going to be the term instance variables. Okay. So these are the instance variables. Now, they're specific type of variables. They are belonging to objects. We have regular variables, but instance variables are variables used for the characteristics of the object itself. So when I'm thinking about my house, the instance variables might be window, door, color, all right, and maybe, how many dormers are on there, things like that, the specific characteristics. The methods are the behaviors, and we use the word functions in this course. Those are the actions. Those are the things that I can use to act upon my house. And so those might be the things, for instance, opening and closing the door. All right, opening and closing the garage door or a window, or actually functioning on something else within the house. So some things about objects and their creation is I need to be concerned about data hiding. And so what it's doing is it's restricting access to certain members of the object. All of those instance variables of an object will have a private visibility. So we will not be able to access them directly, unlike things that we have been working with previously. So it is a public interface, but the idea is that inside of the interface, I am going to declare some of those things to be private so they can't be accessed outside of the interface. Members of an object are available outside of the object. This allows the object to provide access to some data. and functions without sharing its internal details and design. So when we think about things that actually are objects, so like your account, if you have a savings account or a checking account, and you also have an ATM card to work with that, there are private values of your account that you don't want people to know, like maybe your account name, your account number for sure, and your PIN number. So those would be those characteristics about the account, okay, that you don't want people to have direct access to. However, there are actions for which you can perform on your account. The ability to make a deposit, to withdraw money, write a check if you have that capability. So think about a bank. A bank is made up of thousands of account objects, but all of those accounts share the same attributes. So every time somebody opens up an account, it's creating a new object within the bank. So a class has a name, and the name of the class will always be the same as the objects from which I will create within the class. Now we're going to integrate our class within our main class that we've been writing thus far, just for ease of creation. That will expand next year. But the idea to have a class name, so maybe this one I would give it account to demonstrate my account. And then in there, I'm going to declare a variety of items. I will declare my private variables, private instance variables, okay? And then I will provide the public actions, which are the public functions. Some functions are private, things that might be done internally, for instance, in a bank, the ability to add interest to an account. That is done internally through the bank. It's not something that the actual client can do to their account. So that might be a function that would be declared to be private versus the action of making a transfer or a deposit or a withdrawal. Those would be actions that need to be public to the account so the account can change and shift money around. So here we have an example of a rectangle. So rectangles' characteristics are dimensions. So they use the private variables width and length. They are declared private, so I can't access them directly outside of the class. So their scope, if we remember the idea of scope, is limited to the functions within the class itself. So all of these functions have access to these two private variables. However, anything outside of the curly braces do not have access to the direct width and length of the object. All they can do is call to get that value, okay, of the length and get the width of the object. So here we have our instance variables. Those are the private members of the class. And then these are the public functions of the class. And so these are the actions that I can take on a class. Okay. So if we think about our account, it would be laid out the same way in terms of what some of those private variables were versus what would be public. So we use control access members of the class. We have to control that. That's that idea of that information hiding. We also call that encapsulation. And so we have the public visible modifier and we have the private visible modifier. And so those things that are declared to be public can be accessed from outside of the class. Those things that are declared to be private can only be accessed from within the class by the members of the class. And so like when you call on the math class to get the POW function, it is a public function, and that's why you are allowed to access it. All right. If it were private, you would not be allowed to access it directly like we do in a math expression. So again, as I described earlier, the private members of the class and then the public members of the class. So in order to define a member of the function, okay, we do need to still think about our prototypes, and we'll look at that a little bit later on. But then we also need to define the function's class name and the scope. And this is a little unique to the language, and so we use the scope operator. Those are two sets of colons. And so what that is telling me is that this function here is a member of this class. So this function is a member of this class here. Remember, rectangle was the name of my class. We already know the idea of void. Void does not return anything. All right, so this happened to be a member of, and so its scope is only that of a rectangle class or a rectangle object. And in this case, this one is just setting a width. It's, maybe I can use it to reset the width of my rectangle. But here is the private variable. This is the private instance variable. All right. And then this is the value that is passed, and that is passed from int main or some other function that is executing it. All right, but the idea that only a rectangle can call on set width is what this function header is telling us about my class. We will also create accessor and mutator methods. If you remember, I could get the width, I could set the width, I could get the length, I could set the length. And that is standard, is to have a set of accessor and mutator functions as they relate to the private members of the class in the event I want to update those members of the class or be able to retrieve them. Remember, they were all private, so in order to get them, I needed a means, and so that public function is my access, that pathway to getting the value of the private member. It also is my access for, if I wanted to reset the width. And so, for instance, your ability to go to an ATM in your account and call on a withdrawal is an accessor method allowing you, or actually to get the balance, you would use that more as to get the balance of your account, okay, not to withdraw. But again, withdrawing is going to update or mutate your balance. And so again, that could be a form of a mutated function for your object, is the ability to update. So we will pick up with part 2 in our next video.